Welcome everyone to our Dorsey Power Hour. Today we'll be talking about the basics of air distribution and understanding the product and application. I'd like to introduce our Dorsey team. We got three sales engineers over in our Seattle office. We got Scott Boucher, Chris Wooldridge, and John Neeson. I am Blake Bonham. I'm over in the Spokane office serving as a sales engineer. A couple of housekeeping duties. We're going to mute everyone during the presentation just so we have clear audio. So if you have a question, please enter it into the chat and we'll either answer it in real time or we'll wait when it's appropriate to answer that. So go ahead and enter that in the chat if you have any questions during the presentation. And we'll answer questions at the end too if anything comes up. I'd like to introduce our speaker who has been with Greenheck a little over 3 years, but has been in the industry for about 30 years. We have James Fry, who will be speaking today. And James, I'll go ahead and hand it over to you.
Well, good afternoon, everybody. I'm on East Coast time, and I guess you're on Pacific time. You're getting ready for lunch, and I'm getting ready for happy hour. So we'll go through this situation, go through the basics of air distribution, kind of introduction to Greenheck in the GRD world. We're excited about that new business venture, and I'm going to start to share my screen if that's okay. All right, air distribution fundamentals. And again, there's my email address if you have direct questions for me or go through your Dorsey team. It's preferable. I just want to talk and give a plug to Greenheck as far as what we're doing in the industry. 3 years ago, Greenheck made plans to get into the air distribution business, and we could consider that the power of the package. They've got very strong representation across the country with fans, dampers, louvers, hoods, DOAS units, and so forth. And so they wanted to add to that repertoire and give the reps another option to provide a packaged proposal. So 3 years ago, they wanted to get into business. They did not want to reinvent the wheel. They didn't start from scratch. So they made an acquisition. And that acquisition was Metal Air. So another company with over 75 years of experience in air distribution, manufacturing, engineering. And they've got the great mindset of doing the customer service and quality production. Through those resources that Greenheck has, they've made some immediate improvements already in our manufacturing facility. We have 3 different manufacturing facilities: Bushnell, Florida, Marion, North Carolina, and then Reynosa, Mexico. And all these products are getting to be automated by the resources and engineering from Greenheck. So there's a kind of a video of our brand new transfer press, a 400-ton product. It takes a roll former, and it will produce back pans for many of our sealant diffusers in 4 seconds, where possibly it took maybe 2.5 minutes before without the same quality. So we got some repeatability, some quality there. We can draw that into a 2-inch neck with a beaded collar. It's very nice product. And we also have improved our automation. So again, that's our repeatability and our productivity and our quality. It adds to our superior lead times. Our lead times are typically 2 to 3 weeks on just about everything we manufacture in our Bushnell plant. We've also added a brand new paint system. We subscribe to the ecosystem, not the Powderco system. We prefer the ecosystem. It gives us more flexibility and better coverage. So we've got a brand new wash down system and a brand new spray facility there in Bushnell. What we're going to cover today, we're going to cover a few goals. This is our agenda. This is not limited to this, and it's not in any particular order, but we're going to talk about goals of air distribution. What's the thermal comfort definition? Some terminology that we typically use might be very elementary to most of you, but it's something that needs to be understood. Different applications for air distribution, some throw corrections and importance on heating to cooling and adjustability, and of course we've got some kind of design concerns that we can also talk about. What is an air device? Extremely simple, correct? But that's what it is a product that delivers the air to the room. We provide comfort to building occupants. You all, the mechanical engineers, give a lot of consideration to the overall design of the equipment, the loads, and such. And so right down to the very end of it, we got to make sure that we select the air distribution properly. All that other design work goes for naught if you're not delivering the air properly. So, humidity, goal number one, humidity. So air distribution rarely, unless you're into terminal units, rarely changes the thermodynamics of the air distribution. But, in ASHRAE standards for maximum comfort, where we're looking at 30 to 60 degrees, 30% for maintain your healthy level. So that's your target. But, how we place the air distribution, how we deliver it is important. So humidity is part of that. Air velocity is one thing that we can do about. We talk about how we're going to place that air distribution where it's going to be delivered to the occupied space where that zone is important. So air velocity is very important. That's one thing that we can control. Radiant temperature, when you're selecting your air distribution and placing your air distribution, you need to know how many people are going to be in that room. Everybody off gases a little bit differently. Your latent load, such you need to take into consideration, and where you're going to consider where you're going to throw that air so it's not drafty on somebody. Metabolic rate again adds to the discomfort of a room or the occupants. So there's a lot of different settings there. So you got somebody sitting, you got one factor, and you got somebody running at 8 factor. So knowing what they're going to be doing at the room determines on how many pieces of air distribution and where they're placed and what are they clothed like. And there's a psych chart that tells you, you've got a factor of 0.5 and all the way up to a factor of 3.5. So what do they do? Is this a warehouse? Is this a working facility? Is it a gym? Is it a school where students are coming in and shedding layers of clothes? So that's one of the things that's considered on your part for selecting the proper air distribution and placement of it. As defined by ASHRAE standard 55, relative humidity, we're targeting 30 to 60%. Air velocity, we want to deliver the air at 50 feet per minute to the occupied zone. We don't want to be over that. They'll be drafty, or less than that, we won't feel a thing. It won't mix into the room properly. A perceived temperature of 73 to 77 degrees. And, we typically, a goal of our thermal comfort, we typically are satisfying 80% of the occupants. Hard to make sure that everybody's satisfied. So there are certain products that we offer that can help distribute the air or vary the air in areas where that other 20% is uncomfortable. Minimizing drafts, knowing your room, knowing your layout, knowing what there. You got your vestibules, you've got windows, you've got through the wall units, things that we want to take care of as far as drafts are concerned. So we want to reduce the perceived velocity of airflow. This is a diagram of what our target is, our stabilizing our temperature. When we leave the diffuser, we're leaving the face of that diffuser probably somewhere around 500 feet per minute. So what our plan is to induce that air into that room and mix it properly. Our discharge temperature could be around 55 degrees, and we want to mix into that room to get a desired temperature of maybe 73 degrees. Our occupied zone or our target zone is in the diagram to the left there. We want to be 3.3 feet from an outside wall or window, 1 foot from the interior of an interior wall. From the floor level, 3.5 feet for seated people and 6 feet for standing occupants. Knowing your occupied zone and your target is important when you place your air distribution. So we're going to deliver that to that occupied space at less than or equal than 50 feet per minute into that zone. Understanding the placement of air distribution is also understanding how the air comes out of the diffuser and how it reacts into the room. The Coanda effect is utilized in our performance data as well as everybody's performance data. So the Coanda effect is a tendency of the fluid jet to attract to a nearby surface. This principle is named after Henry Coanda. So as this diagram, you have a high sidewall supply register supplying air to that room right next to the ceiling level. That air will apply itself and stick to that ceiling and go along that ceiling before it entrains into the occupied space. Typically, we consider that to be about 30% add and throw. So our performance data, when we show you on my chart, takes in effect the Coanda effect. If you had a non-ducted or a ducted application with a non-ceiling or non-wall, you would have to take a deficit of 30% for your throw. This is our test lab in Clearwater, Florida. This is where we do our standards as far as demonstrations and testing. So this is kind of demonstrating the quantum effect, how that came out of that plaque diffuser and held onto that wall until it entrained into that room. It'll hold onto that wall till about between 70 and 100 feet per minute, and it'll start to separate from the ceiling, and then it'll entrain into that room, into your occupied zone. Some terminology that you should be familiar with as you look at our selection tables: velocity. Velocity is the speed of and direction of motion for a fluid or an object. We catalog our data at terminal velocities of T50, T100, T150. That's 50 feet per minute, 100 feet per minute, and 150 feet per minute. So a typical example, say 10 feet away from a diffuser, the air velocity is 100 feet per minute. So we'll show you in 3 different factors how far away you are at those particular set point velocities. Why it's so important. So here's an example of a ceiling diffuser discharging in 4-way blow at 150 feet per minute, and at 100 feet per minute, and then at 50 feet per minute. All this data is cataloged and logged in at isothermal air. Another terminology that you should be familiar with when looking at our charts is the pressure. Static pressures is exerted equally in all directions without air movement, can be measured directly. Inflating a balloon increases the static pressure inside the balloon, and velocity pressure is releasing the balloon. It cannot be measured, it's only calculated. So total pressure equals velocity pressure plus static pressure. This will be data points on our performance chart. We also catalog by NC criteria produced by disturbances in the surrounding air, which may be caused by vibration, a single impact, or series of impacts. So sound is measured commonly using the NC level in this industry as opposed to octave bands. Why? Because it's a single point value that we can easily compare ourselves with other manufacturers. So commonly used in interior buildings, the NC levels are single numbers rated to describe the spectrum of measured sound levels in conditioned spaces. So here's a chart showing that the highest pressure point is going to be the NC level catalog for that device. There are main product types of air distribution. Typical terminology: ceiling diffuser, a device that's mounted obviously in the ceiling over above. You've got linear diffusers. There's several different categories for linear diffusers. There's bar grills, slot diffusers, plenum diffusers, but those are all linear products. Grills, typically mounted in a wall or a floor without a volume device. And then registers. Once you add a volume device to a grill, then we designate it as a register. Here are some air devices and their functions. We've got round diffusers, which has a 360-degree pattern, typically a shorter throw, but very uniform in 360 degrees. We have directional products, our 5500, which we call louver face diffusers. These can be ordered in different core patterns. You have a longer throw pattern as you reduce your blow from 4-way down to 1-way pattern. And we have high induction products where we can take and induce the air very rapidly, mix the room air so you can mix as well. And we can if you had a room that had low airflow, we would highly suggest you do a high induction product where you can induce the pattern into that room and mix the air to your desired temperature. Here are the examples of those blow patterns in our demo room. The 5750 is a 360-degree pattern. It's completely round. You would think that's a 4-way pattern diffuser, but it's not. Comes out there very nicely in a 360-degree pattern. Here's this one. The 5500 is a product that's a little more distinct in pattern control. You can see the 4-way pattern there. And then again, example of our high induction product. a room that might have a limited airflow or low temperature, it would hold the ceiling well. This forces it to get down into the room and mix to the room to get to your desired temperature in your occupied space. I want to give you an example, just a kind of a comparison from the 5700, which is our square cone diffuser, to our 5750, which is our plaque diffuser. The back pan is identical on these two products. Both products are a 360-degree pattern, and there's another view of it right there. Holds that ceiling very nicely, utilizing Coanda, comes across there and then drops into your occupied space. Both of them are fairly identical, though the left one has another set of louvers on it. Here's an example of turn down. The one on the left is at 350 CFM. It's 10-inch round neck. And I'm showing you at this application if you were in a VAV system. So if your VAV box is maximum set point at 500 CFM for that diffuser, that would be the blow pattern on the right. If it was set for if in turn down, be 350 CFM on the left. So we're showing and demonstrating the fact that you have good turn down and good similar blow pattern distinction between these two products. I'll show that one more time. See, even though I got 350 cm on the left, it does not dump the air. It comes out very nicely and holds that ceiling until we need it to drop off that ceiling at 70 feet per minute. Some mounting considerations when you're deciding what type of ceiling you're going to use. We can provide different mounting styles for all of our air distribution. So typical terminology, we would lay-in mounting or T-bar grid ceilings. This was an example of that. Note that you're going to have a smaller duct connection because you're going to undersize the deck to fit the 24 or the 48-inch T-bar spacing. Surface mounting, so your next size will be the full dimension of the duct that you required, and you can mount that to a gypsum board or drywall ceiling using face-mounted screws or hanger brackets. Here's an example of hanger brackets. This would be concealed mounting, we would call that. Not using a face-mounted screw, it's a cleaner look from the face of the diffuser. Here are some examples of mounting sealant diffusers this is our model 5700, which is a square cone diffuser. You'll notice the back pan is a one stamp piece. That's what's going through our transfer press. The very first product there, the surface mount frame 1, I've got a dotted auxiliary frame there. That's what we suggest you do when you use a surface mounted in this particular style diffuser. The auxiliary frame actually turns a lay-in diffuser into a surface mount diffuser. Advantages here, you have a cleaner installation. It's much quicker for the mechanical contractor, and it gives you a free access point above the ceiling. At this point in time, if you had a surface mount frame 1, you would have to remove the diffuser from the face of the diffuser and drop the ceiling and drop it down to get access above the ceiling, or add an access panel. This particular installation gives you a free access panel and access to the ceiling. The next one over, the lay-in diffuser, self-explanatory, very typical for that style diffuser. You have lay-in panels, conceals pline, and what we call bolt slot or Dom fine line is also available. When surface mounting a louvered diffuser, typically our model 5500, you'll see that the surface mount, the very first product on the top left, surface mount frame 1, this is a very difficult application to install. Your ceiling opening is probably 1.5 inches larger than your neck size, and your diffuser recesses up flush with the ceiling. It might be a decent, very hard to frame up and support that diffuser in that ceiling without face-mounted screws. We highly recommend that you move over to frame 2, the bevel frame. That surface mounting diffuser is a lot easier to install for the contractor. It gives a cleaner look. Your ceiling opening is the exact same size as your neck size of the diffuser, and it adds a smudge ring, so it's added protection for your ceiling. If in fact this was a fire rated application where you're using a steel diffuser and you're adding a radiation damper to that neck, frame 2 you would not have to use a ceramic or thermal blanket to protect the exposed metal. Your radiation damper will cover enough. But if you use the frame one, you would have to add an additional cost and labor to install a radiation damper to protect that exposed metal. Here's a couple very common installations for our slot diffusers. This is our 6600. They're ice tongue pattern controllers, as you see there. The one on the left is for surface mount, and the one on the right would be for lay-in. We do not like the use of face mounted screws on our linear diffusers. It does not look well, so we recommend this concealed mounting, the concealed bracket there on the left. Our formations product, I just want to talk about our architectural slot diffuser, which is available from 1 inch up to 3 inch in slot width, 2 slot configurations, unlimited in length. But it's important to know that when you order this or specify this product, that you can have 2 different pattern controllers. The pattern controller on the top is our standard blade pattern controller. It slides left and right to give your pattern. That would be a nice discharge across your ceiling and hold that ceiling very nicely. The one in the middle on the top frame would be called vertical. That kind of gives you a downward throw, but very limited. So if you had a standard height ceiling of 10 foot and below, that would be a good application. We would recommend, if you had a very high ceiling, to use our combo blade pattern controller. As you see in the middle there, those two products can be pinched together as I kind of jet the air down in a direction that you're desired. Or on the sidewall, we highly recommend use the combo blade pattern controller. So on the lower left is our visual of our sidewall installation. Here we are with performance terminology. So in our website or our catalog data, we have performance charts that resembles what you're looking at there. Under throw, you have 3 different values. Again, we're talking about 50, 100, and 150 feet per minute, or adversely be 150, 150 feet per minute. These are these throw values. The one that's circled there is with isothermal air. The one with the asterisk is non-isothermal air. You will have a different throw value for cooling for cooler air. Here's a demonstration of that 6600 with the pattern controllers and how you can adjust that in the field to get a desired throw that you're looking for. So in our demo room, we've got it set up. This is a 4-foot slot diffuser, 250 CFM. Both these slots are 3/4 inches in width. Both are set up in a horizontal pattern. This is cooling. We will bring that air across that ceiling, nicely holds that ceiling utilizing Quanda. It'll separate between 70 and 100 feet per minute and then train into your occupied space. Our lab tech will show you how to easily adjust those to ice tongue pattern or clamshell, as some might call it, and you get a nice vertical throw, washing down an exterior window or an exterior wall. Throw corrections. So looking at throw corrections, isothermal air again is our basis of our testing. All manufacturers use isothermal air, so it's comparable across the table. Isothermal air is performance allows manufacturers to provide easy comparable data, like I said, and that's all in a vertical, significantly less in a horizontal, approximately 40 to 50% less. Throw could be adjusted 1 inch from 1% from isothermal throw in either direction. So every plus or minus 1 degree of heating or cooling. So in a cooling, 1% less in horizontal throw and 1% more in vertical throw. In the heating, by adversely, 1% more in horizontal and 1% less in vertical. Here's an example. 55-degree primary air, 75-degree room, delta is about 20%. Isothermal air, we're throwing at 20 feet horizontally, 16 feet, and 24 feet for heating. For vertical throw, isothermal air is 11 feet, cooling 13 feet, and heating 8.8 feet. How do we get adjustability if we don't have slot diffusers? How do we get so we can add baffles to our products? So here's an example of our 5700A adjustable on the left, where we have an adjustable deflection vane built into the product, so you can change it from heating to cooling from season to season. The one on the right, the 5700, is just a very good cooling product. It's in the horizontal cooling mode. As you can see here, we adjustable pattern in that horizontal mode. This is cooling. We're going to get that air go across that ceiling very nicely. And in heating, we will, after the heating season, we will take that baffle, turn them up, block off that cone, and the air will be forced out to the outer cone and down into the room straight down. Here is a visual of that in our test lab. .225 CFM, we've got a 10-inch neck, horizontal cooling discharge on the left, vertical heating discharge on the right. Another look at that same test. Why throw matters in your selections. Here's an example. I've got a 470 CFM diffuser, 12-inch round neck, 600 feet per minute. So a 5500, our louvered face diffuser, we're at 24 feet at our terminal velocity of 50. And perforated diffuser, we're only throwing 13 feet at 50 feet per minute. A round diffuser, a 360-degree pattern, it's got a little better throw, but typically this product is used to get the air from a high ceiling down to the floor. So this is going to be at 18 feet. And a product that we would recommend for high velocities and large volumes of air, a drum louver, we could throw that same amount of air 42 feet. Here's a visual of a drum louver in our test facility where we test all of our products to make sure that they match our cataloged performance data. This is showing that 42-foot throw from a model RL. Some folks call that a drum louver. Again, back to our cataloged performance data. We catalog the sound again and NC levels, and we let you know what your static pressure is going to be. We test to ASHRAE standards, ASHRAE 70 and ASHRAE 62.1. And here's a list of recommended NC levels cataloged by AHRI. As you'll see that when you make your selections, that you could select your selections by the application, whether you're in a classroom, library, performance hall, hospital, such that shows you the NC level that you should select by. Another way of delivering air to a room that I wanted to briefly talk about is displacement. Not certain if you're in a displacement market, but everything we've talked about so far is induced air. We're mixing the air intentionally. We're bringing the air in and churning it up, getting to your desired temperature in that occupied zone. Displacement diffuser is completely different. Typically low distribution at the floor level. There's different applications as far as in the wall or in the middle of a room or in a corner. We're going to deliver the air as maybe 80 feet per minute from the discharge of that face of that diffuser. It's coming out very slow, very quiet, low cooling. So it's going to reach a heat source. So once it reaches that heat source, it will convect up. It'll displace the contaminated or hot air to a higher return. See, as it walks to our lab tech, the air will start to convect up to him. It will do the same thing with computer, electronics, lights, same situation. We're just trying to condition the air in where the occupied zone where we are. If you're in an application very, very high ceiling, casino, concert hall, theater, we don't want to condition that air at the ceiling level. We just want to worry about where we're at, saving energy. Some concerns. Here's an example of some colliding airstreams. More is not better. Bigger is not better. You have to provide the right product in that air. So we don't want to put diffusers next to each other. It doesn't utilize the effects of the throw. Here's an example of that same diagram that we showed you. The air is going to come out. Instead of holding that ceiling and going to the wall like we want it to, it's just going to dump straight down and create a draft right in the middle of that room. Have to know what's in the way of that airstream. If there's beams or soffits in the way, we need to make those considerations. All of our products are adjustable from 1 to 4-way blow. Even in this product here, which is a 5700, we could put directional baffles in one side of it to not let that air go across there and hit that beam. Here's an example of a soffit, and of course there's a sill on the right-hand side. Take into effect those items when you're making your selections on distribution. Creating noise through volume devices is sometimes an issue. Here's a slot diffuser with a remote operated damper at the neck of the plenum. It adds about 3 dBA to the face operated damper. If you decide not to use that damper and you want to change the volume of that device at the face by utilizing that pattern controller, you're going to raise the noise level approximately 9 dB at the face. So the proper way, or the best way to do it, if you're considering noise, is to remotely do it, get a damper away from the neck of that diffuser by at least 5 feet. All this comes with a cost. Sometimes it's important to know what you're looking and what you're specifying. You want the right product, but you know, some people try to save money with that perforated product that's much cheaper than our louvered face. The plaque diffuser and cone diffuser are very similar in pricing. The perforated diffuser is the least attractive as far as performance. Louvered face diffuser is the best for throw, and you got some very good flexibility there with the different cores. Sound level, again, the louver face outperforms, our 5500 outperforms the others. And pressure drop. The perforated has a higher pressure drop. Utilizing your caps program in their downloadable caps. Well, let me back up. The eCaps version of the Greenheck program, you can find the static performance that I gave you examples. The catalog data, the static performance, the static submittals are all available through eCaps right now. Through the downloadable caps, you can go in and make your selections through knowing our model number, or a quick lookup by a description of product, or you could look up through a cross-reference if you're used to using price model numbers, Titus, Kruger, Tull, and Bailey. We have all of our competitors in there, and you can find our model number by selecting theirs. Once you make that selection, in the lower right-hand column, you'll have what we call, again, a static submittal or a static performance chart, like we used in our examples back there, a Word document spec, and a flow chart for your use. A picture, of course, with a brief description showing you that you've selected the right product. Highlighting that, the next window, you'll start to configure your product. You can put your neck size, module size, whether you're using dampers, insulated backpan, how it's going to be mounted. All that stuff is your configuration. If you want to go to the next level, you can put performance in, adding your CFM. We will give you an automatic calculation for a dynamic performance. You'll get your throws at 50, 100, and 150 feet per minute. You'll get a dynamic noise criteria level and pressure level. So that can be printed to a PDF, create a schedule for your drawings, or just to save it later for reference to other submittals. That's all available right now in Greenheck Caps downloadable version. Through the website or through the selection through caps, you can do a couple selections through a flow chart or a spreadsheet. The flow chart on the right, which is ceiling diffusers, there's a flow chart for each family of air distribution for linear diffusers, wall grills, industrial products, VAV diffusers. They're all there. So you can click on those, hyperlink it. It'll open up a static submittal and a static performance that would be catalog. On the left is a performance perforated diffuser example for our spreadsheet. We have, as you can see there, over 10 different model numbers of perforated diffusers. It can be quite cumbersome. So if you knew exactly what you're looking for, say I wanted a 20 by 20 face, I want it to be all aluminum, square neck, I can see that I need to select a model 7000. So it saves me from going and hunting and pecking and going through each of these products and deciding which product is best for my application. And that's all I have for the fundamentals of air distribution. I wanted to give a plug to the everybody that's on this thing that we do also offer the terminal unit fundamentals program. We can go through VAV boxes and fan power boxes and the functionality of that. And also what's very important into our third business segment in air distribution is healthcare and laboratories. We have a distinguished engineer that's on our staff, Matthew McLaren. He sits on the ASHRAE Standards Committee, and he does a designated lunch and learn just for critical environment, healthcare, OR, and laboratories. So get with your Dorsey team, and we can get that arranged for you. I'll stop sharing my screen now. Blake, are you there?
Yep, sorry.
That's okay.
Had to pop out for a sec.
Yeah. Any questions or any concerns? Anything that I could explain a little differently?
We had no questions in the chat, so hopefully everyone got the full Prezi. And I will wait one more minute for anyone to enter any questions.
Yeah, it was obviously a ton of information. So, while we have our resource here, please feel free to ask some questions.
Yeah, one thing I did want to point out, sorry about that, is for those of you using desktop caps, this coming Monday is going to be your next update. So if you are actively using that, please do the update because Greenheck is adding models all the time, and things change as well with motors and things like that. But your update is going to be available when you log in on Tuesday morning. And if you're using eCaps, that's when they also update that version as well.
Looks like we have a question. Thanks for that explanation, Scott. So Jack Burgess, I don't know if you can see the chat, James, but
yeah,
oh, you can see it? Okay.
I'm looking at it, yeah.
I'm glad Jack asked that.
What?
I was actually going to bring that up if he didn't.
So you're delivering air directly to a space from an energy recovery device.
Yeah,
And
in our climate, it can be, depending on the efficiency and effectiveness of your device, and if there's any supplemental heat, it might be getting delivered anywhere between 50 and 55 degrees. I think a lot of times we try to make sure you're getting close to that neutral air condition. But sometimes, yeah, it's a small amount of air, and you don't want to dump it right in a corner. So it's probably what you're looking for is a high mixing device immediately. Jamie, if you want to give a shot at that.
So you're bringing outside air unconditioned and put it in space to be picked up as outside air, like for a school requirements for ventilation requirements.
Correct.
Is that right? Is I understanding that right?
Yes.
Yeah, you certainly don't want to blow that directly down on anybody, do you? I would suggest that you would use a high induction type product that you would mix it in the room quite, like Chris said, possibly,
Is it the Phenomenator? Is that the name of the model? It's a high induction model for lower CFMs.
Yes.
So we do have a product like that.
Or if you went with our 5500 with the changing out the cores from a one-way blow to a four-way blow. You could direct it in a, away from everybody.
Excellent. As Scott mentioned about caps, if you go to ecaps.greenheck.com, you'll also see the air distribution and terminal unit products listed as a nice little decision tree based off your application, whether it's supply or return or critical environment, whether it needs to be a perforated plaque or cone. And it's wonderful. It leads you right to the product and performance pages. So with that, Blake.
Yeah, thank you, James, for presenting today. Greenheck's got a great team for GRDs and every product you can think of. So thank you again, James, for presenting. Next week, we hope you tune in for our next Dorsey Power Hour, and it's on fan arrays. I believe that'll be one of our last ones. So thank you, everyone, for joining us today. You could see this. We got it recorded on our YouTube page. So if you want to go back and look through it again, feel free. So until next time, thank you, guys.